Hello and welcome everyone. In this video we will see how to perform the basic commissioning of the TPD500 using the Keypad, which is included as the standard equipment with every TPD500 drive. The Keypad allows you to set and manage all drive parameters without a PC. For this video tutorial we start from the condition where the drive is already connected to the mains and to the motor. Before starting the commissioning process, let's quickly see how to use the main buttons of the keypad to navigate through the menus and the set parameters. Pressing the E button lets you enter and select the menu or parameter. It also used to confirm a new value after editing a parameter. Up and down buttons lets you scroll through menu or change parameters value. And finally, left and right buttons lets you move between menus and submenus or shift the cursor when editing parameters value. To start the commissioning, just make sure that the armature and the control board are powered. There is no need to power the field at this stage. The setup we are going to use also includes a control box, which allows to send enable and the start command to the drive, and also to manage the speed reference using a potentiometer. Finally, make sure you have the nameplate data of the motor and of the speed sensor used for the feedback. In this example, the speed sensor is a Tachogenerator. Let's get started. As first step, use the keypad to access the Startup Wizard menu. This is a dedicated menu that guides you step by step through the basic commissioning of the drive, showing you which parameters need to be set. In this first step, you are asked to enter the main parameters of the drive. The armature current is read-only, as it depends on the drive size, in this case 20 amps. As for the field current, the default value is the maximum supported by the drive, in this case 6.25 amps. However, we recommend setting this parameter and adjusting the S14 dip switch on the control board accordingly to optimize the current scaling based on the motor being used. In our example, the motor's nominal field current is 1.4 amps, so we'll set the parameter to 2 amps and configure the S14 dip switch accordingly, referring to the tables provided in the manual. Finally, we can leave this parameter set to off, since in this example we are not using an external 4-quadrant field controller, which would allow motor reversal when paired with a 2-quadrant armature converter. In this second step, you are asked to set 2 additional key parameters for drive management. The first one is the full-scale speed in RPM. This value affects all speed-related parameters of the drive. In particular, it also sets the full scale for the analog inputs that will be used to provide the speed reference. Since the motor has a nominal speed of 2370 RPM, we set the parameters accordingly. The second parameter, main commands, defines how the drive is controlled. In terminal mode, control signals come exclusively from the control box. In digital mode, the control is managed via a digital communication channel, such as Modbus TCP, but terminal signals are still required. For this example, we select terminals mode, so commands will be sent only via the control box. In the third step, you are required to enter the motor nameplate data. In this example, set both the motor rated speed and the motor maximum speed to 2370 RPM. Depending on the motor and the application, the maximum speed may be higher than the base speed. In such cases, field weakening is necessary. Next, set 15.8 amps as the rated armature current, 400 volt as the rated armature voltage, and finally 1.4 amps as the rated field current. Continuing with the steps, now we need to select the feedback signal to be used for motor speed control. As mentioned at the beginning of the video, in this example we will use the Tachogenerator. Therefore, we can skip the next 2 steps and move directly to the Tachogenerator configuration. As with the motor, we also need to rely on the Tachogenerator's nameplate data. The Tachogenerator provides 60 volt at 1000 RPM. Considering that the maximum speed set earlier is 2370 RPM, we expect a maximum output voltage of about 142 volts from the Tachogenerator. For this reason, we select the closest higher available value, which is 181.6 volt, and set the S4 dip switch on the control board accordingly, following the table provided in the manual. Finally, for the TACHO voltage scale, we keep the default value of 60 volt, since the Tachogenerator provides 60 volt at every 1000 RPM. In this section, you are required to set the limits for speed, torque current, and field current according to the specific application. In this example, we keep the default value of 0 RPM for the minimum speed in both directions of rotation, and 4740 RPM as the maximum speed for both directions as well. This value corresponds to twice the full-scale speed set earlier. Regarding the torque current, we leave the default value of 100%. This percentage refers to the rated armature current we set earlier. Finally, for the field current, we keep both default value, which are also expressed as a percentage of the rated field current. The minimum value, 30% in this case, corresponds to the field current when field weakening is enabled at 0 speed. In this section, you are required to set the basic parameters for configuring the speed reference. For this example, we keep analog input 1 assigned to ramp F1, so we can set the speed reference using the potentiometer on the control box. We can therefore ignore the next parameter, which allows you to set the desired speed value directly without using the potentiometer. Continuing with the commissioning process, this next step is one of the most important. We are now going to perform the current regulator auto-tuning. This is an automatic procedure that calculates two key motor parameters, resistance and inductance. These values are essential for the operation of the predictive current control, which is enabled by default and provides better performance than a traditional PI controller. To start the auto-tuning, close the enable input on the control box. Please note, depending on the motor, the procedure may take a few minutes. You can stop it at any time by pressing the ESC button or by disabling the drive. When the procedure is completed, remember to open the enable input again. We are almost at the end of the commissioning process. In this section, you can configure the field control parameters. By default, field control is enabled, and we will keep it that way. As for the mode, we select current control, since we don't need to apply field weakening to operate above the nominal speed. Using this parameter, it's also possible to manage cases where the motor field is controlled by an external device, separate from the armature control. For example, a drive from the TPD500 FC series. As mentioned, we keep field weakening disabled, while keeping field weakening at 0 speed enabled, which corresponds to 30% of the nominal field current, as set in a previous step. Finally, we save the parameter to ensure that the defined configuration is retained even after the drive is powered off. The standard commissioning procedure is now complete. By powering the field as well, we can perform a quick test to verify that the motor runs correctly by providing a speed reference using the potentiometer on the control box. During this brief test, we can monitor key variables by pressing the disc button on the keypad. So we enable the drive, we perform the start command, here we can see the speed reference, and here the actual speed measured by the Tachogenerator. Now we decrease the speed again. And finally we stop the motor. That's it for this video. For more drive parameter settings and advanced features, check out the TPD500 user manual in the link below. And don't miss the other videos in this series. If you have any question, feel free to reach out to our field service team. We are here to help. Thank you.